Hey guys, so in this video we're just going to continue on with simplifying equations, continue on with the video I did last. I'm just going to show you a few more examples, a little bit more complex questions to finish off the fluency, get into understanding, and I've included a question from the modeling and problem solving questions as well. So the most complicated you're going to get with these stuff is it's going to add in a power. So if we remember what we wrote down at the top of our page in our rules, which you all should have in your books, it should say a like term is a term that has the same variable raised to the same value, to the same power, sorry. So as we can see here, our variables are a letter, so x and x is the same, and they're both raised to the same power, which is 2. So they're squared. Okay, so if the letters are the same, but the powers are different, then they aren't like terms. But if the letters are the same and they're raised by the same power, then they are like terms. Okay, at the moment we're not looking at the coefficients, all right? We're just worrying about the variable and its power. All right, so this will be nice and easy. If we have 1x to the power of 2 plus 2x to the power of 2, all right, because we know that's the same and that's the same, the like terms, we have 3x to the power of 2. All right, so now moving on, same premise again, all right, so 3y to the power of 3 plus 7y to the power of 3. All right, straight away I know that these are like terms because they're the same variable, same, both y's, raised by the same power. All right, if one of these were 2, one of these were 4 or 5 or 6, that power is different, then we couldn't do anything. But the fact that these are both raised by 3 and they're both y's means we can add them. Okay, so 3 plus 7 is 10, so 10y to the power of 3. Nice and simple. Don't have to overthink it, guys. All right, moving on to example 3. You'll find this style of question the end of some understanding questions, exercise 2. So just a little bit longer, and they've added in some powers, but don't need to overthink it, guys. Again, we look at this straight away, we can see t to the power of 2. I can see another t to the power of 2, so I know that this term here and this term here are like terms. So I know straight away that I can simplify these two right here. All right, I've got 6g and 2g, so I know straight away that these are like terms, and I can simplify that right there. I have no numbers by themselves apart from this -7, so that's just going to stay at the end no matter what of the equation. All right, so we'll start with the t to the power of 2. So if we have 6t to the power of 2 and we have 5t to the power of 2 over here, I can take 6t to the power of 2 minus 5t to the power of 2, which will just give me t to the power of 2. I don't have to write the 1, because remember, just t by itself means 1t. So t to the power of 2. All right, now I can write out the rest of the equation. Minus 6g plus 2g minus 7. All right, now I can move on to the other like terms that I have the same, which will be -6g and positive 2g. So -6 plus positive 2, all right, which will give me -4. So it'll be t to the power of 2 minus 4g minus 7. And that's that. Don't need to overthink it, guys. Move down to our example 4, which will be our modeling and problem solving question. Okay, so just getting you to apply your knowledge and give you a bit of a worded equation to trip you up a little bit. So we have a shape here, and it says write the total perimeter of this shape in the form of an equation. All right, so that we need to take this information here it's given us and put it into an equation and then simplify it. All right, so I know that total perimeter means all I have to do is add up each side of this, and that will give me the total perimeter. All right, so if I have x plus 5, and then I'll add this one over here plus 4, and then I'll add this one over here, plus x plus 2, and then add this one over here, which we can see by the sign it's the same as this one. This will be plus 4. There you go. Now, all I have to do, I've taken all my values, so all that together will give us the total perimeter, and all I have to do is simplify it. This is pretty easy to simplify. We just find out like terms like before. I know I have an x and an x, so that right there and that right there are like terms. So we have 2x, and then we can write out the rest, plus 5, plus 4, plus 2, plus 4. Just add up all these terms, because these are all like terms, because they're all singular numbers by themselves. 5 plus 4 plus 2 plus 4, it gives us 15. So 2x plus 15. And that's how you do a modeling problem solving question, guys.